The term data provenance, also known as data lineage, refers to information about the genesis of electronic resources. Ideally available in machine-readable and structured form, it addresses questions about agents, processes, and entities involved in the creation of a specific resource. This ideally also includes the lineages of any sources the given resource is composed of, which can result in chains of data provenance information, quite similar to genealogies. Considering provenance chains for scientific datasets aggregated from different sources originating from different institutions, which is increasingly becoming common in contemporary e-science settings, reveals the obvious need for a standardized representation of provenance. The PROV Data Model is one such standard, providing a flexible and generic language for describing provenance in structured form. It is centered around three main concepts called agents, activities, and entities, and a set of relations between them, allowing to model provenance views of arbitrary complexity, ranging from simple data flow views to those including responsibility of agents and information about involved processes. Intuitively, the generation of provenance data is considered to be the responsibility of the process which creates the respective resource. While many scientific environments such as workflow execution engines increasingly feature built-in functionality for recording standardized provenance information, many scientific activities still involve custom software which would have to be modified for this purpose. While this is in principle possible for open source or in-house developed software, it is often a resource-intensive activity, and for commercial software in use, it is usually even more out of scope. Many existing software solutions nevertheless provide proprietary output which can in many cases be transformed into standard conforming provenance. A recent proposal for a dedicated standard addressing this issue is called PROV-Template. As its name implies, it is based on the notion of templates serving as a priori specifications of provenance traces, featuring variables for the involved agents, activities, and entities. These variables are to be substituted with actual values when the template gets instantiated, resulting in a desired provenance document. Templates are themselves also described using the PROV Data Model and therefore represent valid PROV documents which can be validated and transformed using existing tools. The mappings of actual values to the template variables are in turn provided in separate bindings files, which have to be created for each instantiation. The latter takes place in a process called expansion, which takes a template and a compatible binding file as input and returns the instantiated result. PROV-Template has the potential advantage that if an existing process output already contains enough information, the creation of the respective provenance data is decoupled from the process, allowing to modify and design the structure of the provenance without having to change the implementation of the process itself. Moreover, templates can be shared between interested parties, bearing the potential to reduce efforts to reinvent the wheel and at the same time lead to more homogeneous provenance representations for similar workflows in different institutions. The ENVRIplus PROV-Template Registry and Expansion Service has been created with this rationale in mind. It is supposed to act as platform for publishing and sharing PROV-Templates amongst interested parties, fostering mutual uptake and reuse. Moreover, it provides a web service allowing to expand uploaded templates with compatible bindings. The main view consists of a scrollable list with the registered templates. Each entry consists of a set of descriptive metadata and a visualization of the template's PROV graph. The latter can be navigated using dedicated buttons. Although the content of the registry is open to everyone, users have to log in for registering and/or modifying their templates, which they can do by choosing one of three popular identity providers. This delegation of authentication to external providers has the advantage that it does not require to store sensitive user information locally. Once authenticated, users can register new templates or modify or delete existing ones they have created. Modification and deletion are enabled via dedicated buttons which only become active for those templates owned by the logged-in user. Registration takes place in a separate dialog where users have to paste the code for the template in a designated area and specify its format in a dedicated metadata field. Before submitting, a validation of the template content is mandatory, realized by requiring users to create a visual rendering of the template code. In case of errors, a message is displayed prompting for correction. Registration is only possible after the template has successfully passed the validation check and all the mandatory metadata fields were populated. The registered templates can also be accessed via the API. A dedicated call returns a list with basic information about all available templates in form of a JSON string. The complete information available for a template can be retrieved by appending its ID to the API call. This command can be further extended for template expansion, requiring a compatible bindings file to be passed accordingly. In this example, this is done via HTTP GET, requiring to URL encode the bindings before appending them to the call. Retrieving the complete URL returns a properly expanded PROV document. A detailed description of the functionality of the prototype is available in form of a manual, and the source code for the components of the service can be retrieved via GitHub.